If you've ever had someone hovering over you asking, "Did you take your meds? Did you take them on time? Are you sure you took all of them?" Yeah, you're not alone. Parents, doctors, spouses, even grown-up kids all do it. And as annoying as it can feel, those worries are actually very real. According to data cited by the Alaska State Legislature, medication mistakes and missed doses are a huge problem. In the U.S. alone, patients don't take about half of the roughly 2 billion prescriptions written every year. About a third of people take only some of what they're prescribed, and another third don't even fill their prescriptions at all. There are a lot of reasons for that, and cost is a massive one. Around 21% of U.S. patients simply can't afford their medication, and more than 2/3 of Americans say medical costs are the main reason they end up bankrupt. The consequences show up in hospitals too. About 10% of hospital admissions are linked to medication noncompliance, costing over $15 billion a year. In nursing homes, it's even worse, with nearly a quarter of admissions tied to missed or incorrect medication use, adding up to more than $30 billion in costs. But even when people can afford their prescriptions and physically get them, there's another surprisingly common issue. They just forget. That's especially true for people who already struggle with cognitive or neuropsychiatric conditions. So here's the big question. What if your pills could actually tell you, or your doctor, that you took them? That's exactly what a team at MIT has been working on. In a paper published in Nature Communications, researchers led by Giovanni Traverso, along with Mehmet Girehan and Sean Yu, revealed a new kind of capsule designed to track medication adherence from inside the body. Each capsule contains a tiny radio frequency identifier, or RFID, that sends out a signal when the pill starts dissolving inside you. After that, the RF chip harmlessly exits the body in the most predictable way possible. Traverso, who's a gastroenterologist at Brigham and Women's Hospital and a mechanical engineering professor at MIT, says the whole point is simple: helping people actually receive the therapy they need so they can get the best possible health outcomes. These capsules can stay intact in the digestive system for weeks and release medication on a set schedule. That makes them especially useful for patients with chronic infections that require long-term treatment, or for transplant patients who must take immunosuppressive drugs consistently to avoid life-threatening tissue rejection. What makes this design stand out is how safely it breaks down. Other RFID capsules have been tested before, but the human digestive system couldn't fully dissolve them, meaning their components either had to pass through the body hole or risk building up inside. The MIT team solved this by using a commercially available RFID unit that's bioresorbable. Its antenna is made from zinc and cellulose, materials the body can safely digest. As Traverso puts it, they chose these materials because of their strong safety record and environmental compatibility. The way the capsule knows when to send its signal is pretty clever too. It's made from a digestible mix of cellulose, gelatin, and tiny amounts of molybdenum, or tungsten, forming a miniature Faraday cage that blocks radio signals at first. Once the capsule reaches the GI tract and starts dissolving, usually within about 10 minutes, it releases both the medication and the RF signal. In animal tests, that signal could be picked up by a receiver up to 60 centimeters away, basically announcing that the job is done. Within about a week, the entire device has completely disappeared.